Let's talk about the second order linear differential equation that is homogeneous. So a homogeneous second order linear differential equation can be in the form of y double prime plus p of x y prime plus q of x y equals 0. And usually homogeneous differential equation have a couple of different ways to solve it. So today we will talk about solving the homogeneous second order differential equation using the reduction of order. So we will use the solution method of the reduction of order. We use the reduction of order method when the problem in front of us is giving the first solution of the equation, which is y1 as a function f of x. So in this case we need only to find y2. So this is the general form of the homogeneous second order differential equation. Now the general solution of this equation have a known form. So the general solution usually looks like this: y of x equals c1 multiplied by y1 plus c2 multiplied by y2. In this case, y1 is given in the problem. You just need to find y2. Okay, let's take an example to clarify the process of solving a second order linear differential equation. This question could be a little bit tricky to solve it. It's a lengthy process to solve it, but it's just simple and the same concept. Now we have a problem saying that solve the second order linear differential equation, which is x squared multiplied by y double prime minus 3x multiplied by y prime plus 4y equals 0. Given that y1 of x equal x squared for all x greater than 0. Okay, now we will start to correlate between our problem and the general form of the second order differential equation. So in this case we can see that y double prime shouldn't have, or should have, the multiplied factor as 1, while here we can see x squared that we're gonna get rid of it. Then we can relate, after that we can relate the p of x and q of x as needed. Okay, now to get rid of x squared we will divide. Let's call this equation number 1 just for simplification. So divide equation number 1 over x squared, and this will make the equation look like the following form. So it will be like y double prime minus 3x over x squared y prime plus 4 over x squared y all equals 0, and we can call this equation 1 prime. Alright, now we can identify that this term is the p of x in the general form, and this term is the q of x in the general form. Now, y1 is given the first part of the general form solution, y1 equal x squared. Now to find y2, let's go here on the side. We have a couple of forms that we want to remember in order to find y2. So in general, y2 equal a variable u multiplied by y1. Now u, in order to find u equal the integration of v dx. Now stay with me. V equals 1 over y1 squared, remember y1 is a given, multiplied by e to the power of minus the integration of p of x dx. So eventually, let's change the color in here. So you found your v, you plug it back in to the u, you found your u, you plug it back in to the y2. So from all of these equations we can find that y equal y1 c1 or c1 y1 plus y2 multiplied by c2. We have y1, we are finding y2 in order to find the general form solution of this equation. Let's get rid of this. So you want to start with v. Now v equal 1 over y1 squared, which is 1 over x squared x to the power 4 multiplied by e to the power of minus the integration of p of x. P of x in here is minus 3 over x dx, and this will give you 1 over x. Okay, now we can find the u, which is u of x. U of x in this case equal the integration of the v, which is 1 over x dx, and this gives you ln the absolute value of x. So this will give you that y2 equal the u, which is ln the absolute value of x multiplied by y1, which is x squared. So now we found our y2. In this case, the general solution of this equation is y equals c1 y1, which is x squared, plus c2 y2, which is x squared ln the absolute value of x. If you want to simplify this form, y equal x squared multiplied by c1 plus c2 ln the absolute value of x, and this is the general solution of the problem shown above.